There are 5 points at which you can reduce ink on an HP low-volume latex printer. And many of these points may apply to other technologies and other printers, including other latex printers, but these are specifically focused on the low-volume latex printers. And I want to go over those 5 points because you can adjust anywhere along these 5 and get results. The first of which is all of the low-volume latex printers have an option to turn from CMYK light cyan light magenta 6 color to 4 color. Immediately that's going to take 2 of the inks, light cyan and light magenta, and then take those out of the picture. And that is going to reduce to some degree the amount of ink you use. Now it's not going to be a lot because light inks do not use a lot. Depending on the image, of course, that can really make a difference, but usually there's a transition point at which the cyan and the magenta come into play, and then you're going to certainly be using those inks in replace of them. But there are ink savings to be had there, especially on the larger latex printers when you're doing larger volume and everything matters. Those small amounts over long runs add up to a lot of ink, and a lot of ink can be a lot of cost. A second point at which you make adjustments is the ink restriction. Now, ink restrictions are reducing the amount of ink per channel. So if you have a print head, say black, and black will put up to 100% ink through that print head, you may achieve the maximum density, which is what we measure on the printer, or the maximum chroma value earlier than 100%. So let's say by printing a chart, you achieve maximum density at 90%. You don't need that extra 10%. It's needless waste. Ink restrictions are very critical, not only for color calibration, but also for not using too much ink. If your ink restrictions are set too high or you have too little of a restriction, that restriction can cause a distortion of the linearization because the linearization is now trying to linearize something that has largely reached its zenith at, say, 90% density. The latex printers have an I1 spectrophotometer on board from the 365 and the 500 series. We use a line sensor as a densitometer for the 315 and the 335, and all of those read a chart based on ink restrictions and then looks at the restriction and establishes a density point, and then that density point allows me to control for how much ink per channel. So ink restrictions are very key. On the latex printers, that can be automated. That is, we have an onboard I1 that as a tool does that automatically to reduce the amount of ink. The secondary benefit of that is it allows you to maintain color consistency because we're going to adjust the ink restriction in a closed loop calibration to make sure that you're printing the target density over time. That's important for a printer to itself over time, as well as it is important to a printer printing to another printer or a secondary printer. All of your clones of your original preset. The third point at which you can control ink is the ink global ink limits. Now, the global ink limits are different than ink restriction. Ink restriction is restricting ink per channel. Global ink is how you combine inks together in 2 colors and 3 colors. For the latex low volume printers, this global ink limit is set when you choose your density at the very beginning. So if you choose 90% density, it uses a global ink limit that is associated with 90% density. If you choose 120% density, it will choose a global ink limit that is corresponding to 120% density. Now, it is possible, if you want to control that a little more on your own, what I might do sometimes is I will go into Onyx. I'm just going to use Onyx as an example. I will go into Onyx and I'll choose 150% density at 12 pass, and then when I get to the global ink chart in Onyx workflow, print the chart, and then I reduce the inks further to control them the way I want to. So in a sense, what I'm doing out of the gate is I'm over-inking it knowingly, and then going into the global ink limit tab and then reducing them very precisely because Onyx has a very elaborate global ink limit chart that will allow you to reduce the amount of ink per channel in the way you choose to control it. And I think for certain prints, especially if I really want fastidious color control, I have been known to do that at times. So far you have switching from CMYK, switching from 6 color to 4 color. That's one point at which you can control the amount of ink. And that's especially valuable for prints when you're printing high speed and other things like that where liquidity really matters. Then you have ink restrictions, which is very critical, very key to understand how necessary that is. And if you don't have a new generation latex printer, that's a really important point where you have to control for. On our older gen, the Gen 1 and Gen 2 latex, it was very critical that you get your ink restrictions right in the rip to make sure you're not putting down too much ink per channel. Then you have your global ink limits, and that's very important. Making sure you're not putting too much ink down in combinations. But if your ink restrictions are way off, it's going to throw off the linearization, and then it's also going to make the global ink limits virtually impossible. So your ink restriction, to me, is the most important step to get right. Once you choose a speed and a temperature, then you have to figure out how much ink you're going to put down, and that's largely going to be decided, your maximum amount of ink, in your ink restriction. The fourth point at which you can control for ink is the Icc creation. Now, the latex inks are very rich on their own, especially black. And what I'm looking to do is, for example, what I use in Onyx when I'm building the Icc profile is I am using GCR+. Now, this is a new feature that Onyx has developed. It saves me a lot of ink. Onyx has up to 30% ink. I could see why. What it's doing is when it's creating black especially, it is using less cyan, yellow, and magenta and just using the black to generate the density or the chroma. The latex inks do not require an enormous amount of CMY to generate black. The black on its own is very rich. So the GCR Plus is a nice tool that when you're printing, say, photographic images, photographs, things with a rich, deep black background, it is not needlessly using too much yellow, cyan, and magenta to generate that black. It honestly doesn't need it. That may have been true in other generations of print technology. I especially used to do that quite a bit in the old days with solvent. But with the latex, the richness of latex black ink, it's not necessary to put all of that ink down. You're just creating needless waste. It's making the printer work harder to evaporate that ink, and you've already achieved it just with the black ink. So the GCR Plus during the Icc creation, for me, is a key setting that I use to make sure that I'm not using needless amounts of cyan, yellow, and magenta. And that sort of brings me to my last point, which is pure hues. So the fifth thing that I do to control for ink is I do use pure hues. Now, I don't always use it in cyan, magenta, and yellow, but I do use it in black. And you might ask, what is pure hues? Pure hues is sometimes called something different depending on the rip, but all the rips provide the ability to send a file over, and if it's just yellow or it's just cyan, and in my case, it's usually just black. So when I print black text, for example, with the latex printer, I have it set to 0000100 in the file. The file then, when it hits the rip sees that it's black only and only uses the black channel to print it. When that black channel only is turned on, then it only uses the black. It doesn't use any of the other colors. What I get is a beautiful, rich, nice text, but then also I have no needless waste of ink, and I'm a perfectly beautiful black without the necessary assistance of cyan, yellow, and magenta. Those colors are not helping me generate black. In some respects, when the Icc is turned on, they may actually hinder me by using less black and more CMY. But keep in mind, I have control for that in the Icc profile creation. So in a sense, I'm doing it at 2 points. For me, with pure hues, anything vector-based lands and goes 0000100 uses black only, so I'm only using one channel of ink. And then any photographic images, raster images, it's using the ICC profile, but the ICC is controlled with GCR+ so that it only uses black ink predominantly and doesn't waste a lot of cyan, yellow, and magenta to create the image. So those are 5 points at which you can inherently reduce the amount of ink being used. It is very important for printing that you don't print with more ink than you need. The goal of printing is to hit your maximum gamut with as little amount of ink as possible. Now that is finally done by looking at the ICC profile in a program that analyzes it so that you can understand where my colors land. Let me give you an example. If I'm using 100% density on a latex printer, and I've applied all of these 5 points of ink control, and I achieve a match on a Pantone color, let's say 185 red, I achieve a delta E of less than 1 on 185 red at 100% density. There's no reason why I would be printing then at 110% density, or 120% density, or 130% density. I have achieved my goal for the customer at 100% density by analyzing the ICC and looking at the Pantone color, which has an equivalent lab value, in a color space that is defined by the ICC profile. All of the RIPs will do this. That is, if you give it a Pantone value or a lab value, it will analyze that within the ICC color space. The ICC is created by controlling for how much ink you put down. As a general rule, the more density, the larger your color space to a point. Keep in mind, this is a 6-color printer. Most people have a 4-color, 6-color, in some cases 8-color printer. And your color gamut is going to be determined by how much ink you put down to a point of diminishing returns where there's no more value to be gained in terms of chroma by adding more ink. But you want to achieve your goal at the least amount of ink possible. So if I can analyze the ICC in Onyx and confirm that my match is already there, then I don't need to be running with more ink than is necessary. I've achieved my target at 100%. And all of this can be done by analyzing the RIP. Once you build your ICC profile, then you have a map of the color at that density. Now, if it falls short, then you might increase to 110% and then run it and look again. Okay, now I'm getting closer. You should be getting closer to a point where there's no more value to get closer. So by increasing the ink, you increase the amount used, but then you're trying to hit a given target. But if you don't have given lab value targets or corporate colors or Pantone matches, you have more freedom to reduce the ink to make it pleasing to the customer as opposed to trying to target match a given Pantone color. Those are the 5 ways that I control for ink. It makes printing more efficient. It makes the printer run better. It allows for you to run faster in most cases with using less ink because you're not putting more liquidity down than is needed to achieve a goal. And your goal kind of depends on what the customer's expectations are depending on what their file is. If you have given Pantone targets or color targets, that's going to be a different goal than just printing pleasing color. But in all cases, you only want to use as much ink as is necessary. Anytime you're using more ink because you're not controlling for color, because you're not controlling your ink restrictions, because you're not controlling your global ink limits, because you're not using an ICC construction that makes sense, or using pure hues when you can, those things will all contribute to putting more ink down than is necessary, and it's going to reduce the ability to cure, it's going to slow you down, it's going to make the prints tacky. With a latex printer, you don't have tackiness, you'll have sort of a watery greasiness, and that means that you have more ink down, more liquidity than the printer can actually evaporate and cure. In which case you have to go back to the drawing board, and for a latex printer, everything is speed, temperature, and ink load. In this case, we're discussing ink load. Controlling for your ink load is very critical to getting results. If you have too much ink or too little ink, you're going to have problems in both cases. The goal is to get just the right amount of ink, and the great thing about the latex printers is that whole process is automated using our onboard i1. Other than the first chart, which you look by eye, and what you're looking for is it dry, is it greasy, and or is it coalescing? So all those things are things you look at. That's how I control for ink. Those are my 5 key points at which I control. If you follow those and you understand those, you're going to get much better results, whether you're printing with a latex printer or any of our other technologies. It still applies to UV, it applies to Gen 1 and Gen 2 latex, it applies to the industrial latex. The principles are the same.